Article 215.2a of the National Electrical Code addresses feeder sizing requirements, specifically focusing on continuous and non-continuous loads. This section is essential for ensuring that electrical feeders are adequately sized to handle the demands placed upon them, thereby preventing overheating and potential hazards. Non-continuous loads are those that are not expected to operate continuously for extended durations. Common examples of non-continuous loads include lighting circuits, electric motors used intermittently, and various appliances that are not in constant use. Article 215.2a stipulates that feeders supplying non-continuous loads must be sized at a minimum of 100% of the calculated load. This means that the ampacity of the feeder conductors must be equal to or greater than the total current draw of all the non-continuous loads connected to it. Continuous loads, on the other hand, are defined as loads that are expected to operate continuously for 3 hours or more. Examples of continuous loads include heating, ventilation, and air conditioning systems, refrigeration equipment that runs constantly, and continuous lighting in commercial or industrial settings. For feeders supplying continuous loads, Article 215.2a mandates that they be sized at a minimum of 125% of the continuous load. This increased sizing requirement is intended to account for the sustained heat generated by these loads and to prevent the conductors from overheating, which could lead to insulation damage or even electrical fires. The application of Article 215.2a involves several steps. Firstly, the electrical designer must accurately determine the nature of the loads to be supplied by the feeder, distinguishing between continuous and non-continuous loads. Secondly, the total current draw of each type of load must be calculated, taking into account any applicable demand factors or diversity factors as permitted by other sections of the National Electrical Code. Thirdly, the feeder conductors must be selected with an ampacity equal to or greater than 100% of the non-continuous load plus 125% of the continuous load. This calculation ensures that the feeder is adequately sized to handle both types of loads without exceeding its rated capacity. While Article 220 of the National Electrical Code provides detailed methods for calculating the overall electrical load of a building or facility, it does not specifically address the sizing requirements for feeders based on continuous and non-continuous loads. Article 220 focuses on determining the total demand load for the entire electrical system, taking into account various factors such as lighting, receptacles, appliances, and HVAC equipment. However, Article 215.2a takes precedence over Article 220 when it comes to determining the minimum size of feeder conductors. This means that even if the overall load calculation under Article 220 indicates a certain demand, the feeder must still be sized in accordance with the requirements of Article 215.2a, ensuring that it can adequately handle the continuous and non-continuous loads connected to it. The 125% factor for continuous loads is not simply an arbitrary number. It is based on extensive research and testing that has demonstrated the need for increased conductor ampacity to prevent overheating and ensure the long-term reliability of the electrical system. When a conductor carries current, it generates heat due to the resistance of the conductor material. The amount of heat generated is proportional to the square of the current and the resistance of the conductor. If the current is allowed to flow continuously for an extended period, the temperature of the conductor can rise significantly, potentially exceeding the insulation's temperature rating. Over time, this can lead to degradation of the insulation, increasing the risk of short circuits, ground faults, and electrical fires. By increasing the conductor size by 25%, the current density in the conductor is reduced, which in turn reduces the amount of heat generated. This helps to keep the conductor temperature within safe limits, even under continuous load conditions. In addition to the conductor size, the type of insulation used in the conductor also plays a critical role in determining its ampacity. Different insulation materials have different temperature ratings, which specify the maximum temperature at which the insulation can operate without degrading. The National Electrical Code provides ampacity tables that list the allowable ampacities for different conductor sizes and insulation types, based on the ambient temperature and the number of conductors in a raceway or cable. It is essential to select conductors with an appropriate insulation type and ampacity rating to ensure that they can safely handle the expected load. Furthermore, the method of installation can also affect the ampacity of conductors. Conductors installed in raceways or cables that are tightly packed together will have a lower ampacity than conductors installed in open air due to the reduced ability to dissipate heat. The National Electrical Code provides adjustment factors that must be applied to the ampacity of conductors based on the number of conductors in a raceway or cable, as well as the ambient temperature. These adjustment factors ensure that the conductors are not overloaded, even under adverse installation conditions. In summary, Article 215.2a of the National Electrical Code is a critical provision for ensuring the safe and reliable operation of electrical feeders. By requiring that feeders be sized at a minimum of 100% of the non-continuous load and 125% of the continuous load, this section helps to prevent overheating and potential hazards. Electrical designers and installers must carefully consider the nature of the loads to be supplied by the feeder, the ampacity of the conductors, the type of insulation, and the method of installation to ensure that the feeder is adequately sized and installed in accordance with the requirements of the National Electrical Code. It is important to understand how to apply Article 215.2a correctly, including defining continuous and non-continuous loads. A continuous load, as defined by the NEC, is a load where the maximum current is expected to continue for 3 hours or more. Common examples include things such as store lighting, HVAC equipment, and similar loads. A non-continuous load is one where the load is not expected to last for 3 hours. General receptacle circuits are typically non-continuous. Motors may or may not be continuous depending on their use. The NEC provides specific calculations for sizing these types of loads. For example, a feeder circuit is designed to supply lighting in a retail store continuous load and general use receptacles non-continuous load. The lighting load is calculated to be 40 amps and the receptacle load is 20 amps. Based on Article 215.2a, the feeder must be sized for at least 125% of the continuous load lighting plus 100% of the non-continuous load receptacles. This would be 1.25 * 40 amps plus 1 * 20 amps equals 50 amps plus 20 amps equals 70 amps. Therefore, the feeder conductors must have an ampacity of at least 70 amps. You must also consider the terminal temperature ratings of the equipment on each end. Section 110.14 C1 discusses using 60 degrees Celsius or 75 degrees Celsius rated terminals when selecting conductors. You must select the appropriate wire size based on the lowest temperature rating of the termination. For example, with a 70 amp load using a conductor with a 75 degrees Celsius insulation rating and terminations rated for 75 degrees Celsius, you would need a 4 American wire gauge copper conductor. If terminations were only rated for 60 degrees Celsius, you would need a 3 American wire gauge copper conductor. Article 215.2a is applicable in many scenarios. Here are some examples. Firstly, a commercial building's main feeder must be sized to accommodate the continuous HVAC load, lighting load, and non-continuous receptacle and equipment loads. Secondly, an industrial facility's feeder supplying machinery and process equipment must account for both continuous and non-continuous motor loads. Thirdly, a multi-family dwelling's feeder to individual apartment units must be sized based on the continuous appliance loads, refrigerators, water heaters, and non-continuous lighting and receptacle loads. It is important to consider any applicable demand factors, diversity factors, and other adjustments outlined in Article 220 when calculating the loads. Demand factors allow you to account for the fact that not all loads will be operating at their maximum simultaneously. Diversity factors account for the fact that not all loads on a feeder will be operating at the same time. For example, a large office building may have numerous receptacle circuits, but it is unlikely that all receptacles will be in use simultaneously. Therefore, a demand factor can be applied to the total receptacle load to reduce the feeder size. The same concept applies to multi-family dwellings, where not all appliances in each unit will be operating simultaneously. Demand factors are typically expressed as a percentage, where a lower percentage indicates a greater reduction in the calculated load. The specific demand factors and diversity factors applicable to a particular installation are typically found in Article 220 of the National Electrical Code. It's important to note that the requirements of Article 215.2a are minimum requirements, and it may be necessary to increase the feeder size beyond these minimums to account for future load growth or other factors. Furthermore, local codes or regulations may impose additional requirements that must be considered. For example, some jurisdictions may require larger feeder sizes for certain types of occupancies, such as hospitals or data centers, due to the critical nature of the electrical loads. It is always recommended to consult with a qualified electrical engineer or inspector to ensure that the feeder is properly sized and installed in accordance with all applicable codes and regulations. While Article 220 provides methods for calculating the load, it does not specify sizing requirements for feeders. It's crucial to remember that 215.2a takes precedence over Article 220 in terms of feeder sizing. Continuous loads are those expected to operate for 3 hours or more, while non-continuous loads are not. Feeders for non-continuous loads must be sized at 100% of the load, and feeders for continuous loads must be sized at 125% of the load. These requirements ensure adequate feeder sizing, preventing overheating and potential hazards. Article 215.2a is not meaningless. It provides specific sizing requirements for feeders based on load type. While Article 220 offers load calculation methods, 215.2a dictates the minimum feeder size, taking precedence in this aspect.